8.4, completing the square. So for this, we're using algebra tiles. Algebra tiles are these things right here. So we have this one that represents x squared, this one that represents x, 1x, and this one that represents your constants, all of your ones. So we're going to use these in order to create all of these perfect squares throughout this lesson. So the first one we have is this one. So we're trying to figure out how we can use those algebra tiles, the x squared, x, and the 1, in order to create this, but at the same time, we need to keep it a perfect square. So, and the square by the definition of drawing as you know it. So we have the x squared block. And then we see that we have two x's. So in order for it to remain a square, we have to put 1 on each of those two sides. And then we have a 1. And it's still a square because the side lengths are the same. So if we look at the left side, we have x squared and x, so x squared plus x. At the bottom, x squared plus x. And then on this side, this is where we want to look at it in order to write our binomials. On the right side, we have x squared and 1. So x and 1. So we have x plus 1. At the top, we have x plus 1. So the area of this square is represented by the length times the width. Our length is x plus 1. Our width is x plus 1. So that's the binomial the two binomials that represent this square. Now, because it's the same thing, we can actually rewrite it using an exponent because exponents mean repeated multiplication. So I have that x plus 1 multiplied by itself twice. So exponent 2. So if we look at this next one, we have an x squared. So we start off there. We have 4 x's. And remember, we want to keep this a perfect square. So what you do on a length, you have to do on a width. So there's 2 of them. 3, 4. And then we have 4 ones. So we have 1, 2, 3, 4. And it still represents a square because we added to the top and to the right. So now at this point, we have x plus 2 at the top and x plus 2 at the bottom on the right. So our length times our width is x plus 2 times x plus 2, and you can shorten that into x plus 2 squared because it represents a perfect square. So same thing with the next one. So we start off with an x squared. Now we have 6 x's. So I'm going to add 3 to this side and then 3 to this side because we want to keep it a square. So then that leaves us with 9 ones. So there's my 9 ones. So when you look at the top side where we added figures and the right side where we added figures, now we have x plus 3 in both places. So we call it x plus 3 squared. And if you multiplied out x plus 3 times x plus 3, you would get this trinomial. So we're just looking at factorization in a different method. So this one, our last one, we have an x squared. This time we are adding 8 x's. So I'm going to add 4 of them at the top and 4 of them at the right. And then we have 16 ones. So when we look at the top and look at the right, we have an x and 4. So x and 4. This side is also x and 4. So x and 4 squared. X plus 4 squared. So this one says x squared is already a complete square. You can see that represented with algebra tiles. What makes this? So we can say this is x times x gives you x squared. That's all it wants there. Very basic. So when we come up here, it wants us actually completing a square. So if we have an x squared and we have 2x, what do we need to add in order to complete it? So that little corner is empty. It's missing one of those little 1 squares. So we have to add 1. The next one, it already gave us the x squared right here. So we have our x squared, and then we have 4 x's, so 1, 2, 3, 4. And what are we missing in order to complete the square? So we have 1 box missing here, 1 here, 1 here, and 1 here. So what's missing? We need to add 4. The next one, it gives us our x squared. It says then add 6 x's. And what's missing? And that's the 1, 2, 3, 4, 5, 6, 7, 8, 9 squares needed to make it a square, a perfect square. So this one is add 9. The last one like this is this one. So how much do we need to add in order to complete it? We need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So add 16. So on the pattern, in class we actually had this discussion about what the pattern was, but somebody noticed that we had to add half of the b value. So we do b divided by 2 and then square it. And that gives you your c value, the c value you want for a perfect square. So on this one down here, where it says complete the squares, if we follow that same exact method that we do, divide by b divided by 2 squared, this, our b value is 10, so 10 divided by 2 is 5. 5 squared is 25. So we would add 25 on the end. Now, if we wanted to factor that as well, we would have x, and because all you need in order to fill in your binomials is that right there. So 10 divided by 2 would be 5, because 5 times 5 is 25, and 5 plus 5 is 10. So this one, we have x squared plus 14x. So if we're going to do b divided by 2 squared, your b value is 14. 14 divided by 2 is 7. 7 squared is 49. So we would add 49 on the end. And again, if we wanted to go ahead and factor that, you only need what's written inside. So we would have x, 14 divided by 2 is 7 squared. So in the next one, we have an x plus 3. So our b value is 3. You take your b value, divide it by 2, and square it. And that gives us 2.25. So we would be adding 2.25 onto the end. So to write your binomials, again, you just need what's written inside here. So that makes a 1.5 squared. 3 divided by 2 is 1.5. So last but not least, this one on the end. Your b value is b divided by 2 squared gives you your c value. So we're going to say plus b divided by 2 squared. So in our parentheses, we want x plus, remember it's just whatever's inside here, b over 2 squared. So when you flip on to the back, it's just more of the exact same thing. So we are completing the squares. The only difference is some of these have negatives. So we'd still do the same thing. So we have our b value is negative 14 divided by 2 squared. So negative 14 is divided by 2 is negative 7. Negative 7 squared is 49. So we're adding 49 here. If we wanted to go ahead and break it down into our binomials, it would be x. Remember, what's inside your parentheses is what goes here. So it'd be minus 7 squared. Because a negative 7 times a negative 7 is a positive 49. Negative 7 plus negative 7 is negative 14. So this one, our b value is negative 12. So negative 12 divided by 2 squared. Negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So we put a 36 on the end. And if we still wanted to write our binomial, negative 12 divided by 2 is negative 6. All right, I'm going to let you guys use the others in this little section to practice, except for this one, because it threw off a lot of people. So your b value here is the implied 1 in front of x. Remember, it's ax squared plus bx. So that b value is the implied 1 in front. So we have 1 divided by 2 squared. So half squared is 0.25, which is also 1 over 4. So we have 0.25 is our answer. So when we put this into our binomials, we end up with what's inside is half, so plus 0.5, or you could have left it as the fraction 1/2. So this next section is having you take out a GCF first, show your greatest common factor. So when we look at this first one, 2x squared minus 4x, they have a 2 in common. So we're dividing the whole thing, including our unknown value, by 2. And that leaves us with x squared minus 2x plus an unknown. So now we're going to do the completing the square like we did in the section above based on what's written in black only. So your b value is negative 2. So we're going to do negative 2 divided by 2, which is negative 1. Negative 1 squared is positive 1. So we're going to put a positive 1 right there. I'm going to change my color so it doesn't get confusing. So put a positive 1 right there. Now, we're not finished yet because we still haven't filled in the blank in the original equation. So in order to do that, 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. So 2 times 1 gives us the 2 that goes in that blank. So if we wanted to break it down, we would go ahead and keep the 2 on the outside. And what's inside is that x, remember, the factor comes from there, so minus 1 squared. So the next one, if I look at this, 5x squared plus 20x, they have a greatest common factor of 5. So we put the 5 on the outside, and on the inside we have an x squared plus 4x plus our unknown. So our b value is 4. So 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. So in order to figure out what that other value is, 5 times x is 5x squared. 5 times 4x is 20x. 5 times 4 is 20. And if you wanted to write this in your binomial, you would have 5 times x. 4 divided by 2 is 2 squared. All right, the last one I'm going to do for you guys is this one, the very last one. So 10x squared plus 10x plus blank. What they have in common is that factor of 10. Remember, it's the greatest common factor. So yes, a 2 goes into both of them, a 5 goes into both of them, but you want the greatest common factor, so it's that 10. So we have 10 times x squared plus x plus the unknown. So now we look at it, and there's our b value of 1. So we have 1 divided by 2 squared, which gives us 0.25. So we have 0.25 here. And then remember, you have to go back and distribute this 10 to get your original unknown, which would be 2.5. And if you wanted to go ahead and put it in your binomials, you have 10 times x plus the inside half squared.